On number 2, we're to find the exact solution algebraically and then check it by substituting it into the original equation. So to do this, the first thing you want to do is try to get the same base on both sides. And since the left side has a base of 1/4, we're going to work the other side to having a base of 1/4. So the first thing we need to do is to get rid of this 32. So we'll start by dividing by 32. And then when we do that, we have 1/4 to the x over 3 power equals 1/16 when we reduce it. Well, we're almost to the 1/4 power on the as a base on the right, but we can write 1/16 as a power of 1/4. And then when we do that, we're all but there. And so 1/16 is just 1/4 squared. And then by our 1-to-1 property, x over 3 has to equal 2. And then if we solve this for x, we would do that by multiplying both sides by 3, which would give us x equals 6. And then we want to verify our answer by substituting it back into the original. So we check to see if 32 to the times 1/4 to the 6 over 3 equals 2. So we're going to simplify the left side and see what happens. Well, that's 32 times 1/4 squared, because 6 divided by 3 is 2. And then 1/4 squared would be 1/16. And if we stick a 1 under that 32, it becomes obvious that we can cancel a factor of 16 and get 2, which is the answer we were looking for on the right, which was 2. So we verified our answer. Now let's look at number 4. Same set of directions. So again, our goal is to get matching bases on both sides. So if we divide both sides by 3, we get 4 to the x over 2 equals 32. And then we want to rewrite, ideally we want to rewrite 32 as a base of 4, but you can't write 32 as a power of 4. So when this happens, come back and look at your original base, which ours was 4, but we can rewrite that as 2 squared to the x over 2, which is going to simplify to, because the 2's would cancel in the exponents when we multiply them because it's a power to a power. So that gives us 2 to the x. So now we can look at writing 32 as a power of 2. Well, if you think about 32, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, means that that is 2 to the 5th. And so again, we're back to using our 1-to-1 property, and this one's even easier once we've done that, because our x equals 5, and then again we go back to substitute it into our original equation to make sure that it works. And we get 3 times 4 raised to the 5/2 power equals 96. Well, we're going to simplify that 4 to the 5/2 first. And remember, a 2 in the denominator of your exponent is a root. So we're going to take the square root of 4 first and rewrite the left side as 3 times 2 to the 5th. Well, 2 to the 5th is 32. And 3 times 32 is 96. So it worked. And we're ready for the next one. Number 8. A little bit different set of problems here. But we're still supposed to find the exact solution algebraically and then check our answer by substituting it into the original equation. Well, the easiest way to do these problems is to rewrite this logarithmic equation as an exponential. And remember, the bases are the same, so I'm going to have a base of, and then what's on the other side over here is my exponent. So 2 to the 5th equals x, and 2 to the 5th is 32, so x equals 32. If we substitute that back into the original equation, we would have log base 2 of 32 equals 5. And then we can translate that equation back into an exponential to help us think about it. Is 2 to the 5 equal to 32? Yes, that gives us 32. So that one too checks out. And then on to number 10. We're going to do the same thing on this one that we did on number 8 with the same directions. So we begin by writing 4 to the first power equals 1 minus x. So then if we subtract 4 from both sides and add x to both sides, we get x equals negative 3. And then we substitute into the original equation, and we get log base 4 of 1 minus negative 3 equals 1. So then we translate it back to an exponential to help us think about it. Is 4 to the 1 equal to 1 minus negative 3? Well, when we simplify the left, we get 4. When we simplify the right, we get 4. So clearly, our answer worked. And that's the end of this video.